Writing chemical equations. So we're going to be going from a word equation that is written out into the chemical equation that is quick and easy to read with the correct chemical formulas, potentially states of matter, and balancing. The process for writing a balanced equation, this is not necessarily set in stone or in the same order, but it's the way I like to work these. First, you want to convert any of the names into the chemical formulas. Be sure that you write the correct formula. Elements from the periodic table do not need subscripts unless they are a diatomic element. Diatomic means di is 2 atomic atoms. They require 2 atoms to be stable in their pure elemental form. These are bromine, iron, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. You can remember this as Brinklehoff, as you know, like think of like I'm gonna go arm wrestle. My name is Brinklehoff. Another way you can remember it is have no fear of ice cold beer. Is another way in which to remember those 7. Those are the only elements that will have a subscript in their elemental form. For ionic compounds, make sure you create neutral ionic compounds, balancing those charges. Covalent compounds, use the prefixes to denote the subscript. The arrow is what separates your reactants from your products, and it's going to be signaled by terms such as decompose, to yield, to form, make, something along those lines. We use a plus sign to separate compounds from each other. Add states of matter, S, L, G, or AQ if necessary. And then once you have all that done, last but not least, you have to balance the chemical equation with your coefficients. So let's do this. All right, we have our word sentence here. I would not take the time to write out the word sentence if it was you, but if you want to, that is fine. You do have them on your guided practice if you printed them out. It is up to you. Solid copper 2 carbonate decomposes to form solid copper 2 oxide and carbon dioxide. I take this one step at a time. All right, reading across. Solid copper 2 carbonate. There I have a compound. So I'm going to take the time to write that compound down. So we have copper. The Roman numeral tells us that it is a transition metal, so that is the charge. Carbonate is a polyatomic ion. You can use your data sheet if you do not have that memorized. So these are both ions, therefore it's an ionic compound. We want to make sure it's a neutral compound. Both have the same charge, therefore it makes it easy for us. So we have copper carbonate. The state of matter follows behind in parentheses of the compound we're writing with. Decomposes to form. That to form tells us we have an arrow. Decomposes just tells us the type of reaction, which we'll talk about later. Solid copper 2 oxide. So I have another compound. So here I've got copper. It's still a charge of 2. Oxygen has a negative 2. Therefore, the charges balance out. So we have a 1-to-1 ratio. And it is a solid. And that's a plus sign. Carbon dioxide is a molecular compound. So that's carbon, di means we have 2 oxygen. So it is CO2. I didn't give you the state of matter for CO2, but you should know the state of matter of CO2. It is a gas. All right? So now I have written my chemical equation, but we're not done. We've got to make sure it is balanced as well. Starting with the most complex, reverse. So we have copper. Carbonate is a polyatomic ion, but it gets split across the arrow. So it's going to be carbon and oxygen that we need to balance. Got 1 copper on either side, 1 carbon, 3 oxygen, 1 plus 2 is 3 oxygen. Balanced, balanced, balanced. Yes! So we're done. This one actually works out to be balanced. It's ones straight across, and we don't have to write those ones.